Okay, welcome everybody. Good to be back in this setting again. Welcome back. Welcome in. So, thanks for putting your names up there. I'll take roll in a few minutes, give people a few more minutes to kind of come on in, and then we will I'll take roll. In the meantime, let me announce a few things here. So, let's see, where are we? Make sure I don't show anything I'm not supposed to because of grades or something. I think we're good. Let's close that one. Move that one over. Close that one. All right, I just want to make sure I don't accidentally have like a tab with grades that all of a sudden pops on screen or something. So, there's a new assignment in Delta Math called the practice exam. So MV35 practice exam. So that's up and going. So we haven't learned all the information yet, and we're still going to learn some stuff today. Oops, what is that? Weird. I don't know why that's showing a blue on my Zoom. Sorry, I got distracted by a weird visual artifact. So, practice exam is up. There's a bunch of problems on it, and it's long. It's longer than the actual test is going to be, but it's going back and it's giving you problems that we've learned over the course of this semester. Factoring. Hold on one second. So there's we're covering factoring, systems of equations. All those chapters that we've covered, those are all on there. So it's a big review. The actual test is going to have fewer problems on it than the actual review, so it won't take you as long. So if it takes you a few hours to do the review, don't panic and go, oh, the test is going to be that long. The test should be easier than that. There was a question. I couldn't hear what the question was. Do you want to repeat that? No? Sounded like there was a question a minute ago. So if someone had a question, feel free to re-ask or put it in chat or whatever you need to do. Sorry, Victor, can you repeat that? I'm getting some weird feedback on your... Oh, when it will be? Yeah. So I'm going to get to all that. I'm going to give you all. Yeah. Good question. I'm going to give you all sorts of information about the test, and then at that point, feel free to ask questions if there's anything I haven't covered. That'll be fine. I don't know why it's not. Let's see. Do I have a setting wrong? Why are we doing this? Oh, it's not muting people automatically. Okay. You can unmute yourself if you have a question, but we keep getting feedback from people when they're first coming in. So, right. So, here we go. So if we go to the academic calendar, oops, I had one open. I must have accidentally closed it here. Let's take a look. So today is what, the 14th? Yeah, the 14th of March. So we're right here on this 14th. Bring this in a little bit here. So we're right here on the 14th. Your test will actually be your test is kind of going to be around spring break. So you'll have a few days to do the test. So basically the way it works is it depends how far we get through stuff today. We might still have some stuff to discuss on the 21st. In fact, maybe you bring me questions is probably the most effective way to deal with the 21st is you bring in questions. We review material that maybe you haven't worked at for a month or 2 months or something. You bring up some of that old stuff. We'll go over it. So the practice test you'll see is not due for a while. And the test itself, I likely won't have due until over spring break. So I probably... trying to think when I should make it available, but I'll probably make it available shortly before spring break. I know some of you are going to do stuff for spring break and you don't want to have your test over spring break. So I'll make sure that you can complete the exam before spring break starts. but it'll be due before we come back. So you'll have to look and pay attention for the actual due date. It'll be in Delta Math, so you'll see it in there. And then watch for the due date. But I know some of you are going to want to get it done before spring break, and if you're if you're responsible and you're studying and that kind of stuff, that's definitely doable to be prepared for that before spring break. Get it done, and then you won't have to think about it over spring break. Some of you will want that time to study for spring break. So everyone has a little bit of a different approach. But I will make the test available probably late in this week, this last week before spring break starts. So like the 24th or 25th, the online test will become available to you. And then it will probably be due, I don't know, maybe the 3rd or something around in there. It'll be due before we come back from spring break. So before we meet after spring break, that test will be due. Okay? So, and this test, try to do your best on it, but don't panic, right? I generally give long periods of time to take the test. So no one... some people want to make a test really fast. I don't see much point in making a test be speed-based, especially since we're not confined to the classroom where we have to be in a classroom at a specific time. So, why limit it to a certain period of time? And some teachers are like, well, if they know it, they can do it fast. I never really saw the point of that. Some people work slower than others. It doesn't mean they can't do the problems. So usually my online tests have you'll have hours and hours in order to work on the test. No one's going to run out of time. It'll just be because you really didn't know how to do the problems is why that will happen. So you'll have plenty of time to do it. And then if you do poorly on the exam, there's a retake that you can do. So if you come in, you take the test, you don't do well, that grade doesn't mean that you can't pass this class. You'll still be able to, fix that grade, and then hopefully have a grade that puts you on pace for passing the class and not having to do the class again. So that's kind of how that will work. So, kind of plan on you'll have spring break to do it. If you want to get it done right at the beginning of spring break, or before spring break officially starts, you'll have that opportunity. If you want to spend that time studying, you'll have that opportunity as well in order to get that done. Let me turn this off here. So you'll have that. So you have the retake. You have plenty of time to take the exam. Let's see. There was something else I was going to say, and then I got thrown off. So let's see. What was I going to mention? I'm sure I'll think of it. Right. I don't know. I'll figure it out. But so you'll have spring break. You're used to Delta Math, so you kind of I know what it was. So what you want to realize is the practice test is set up exactly like a homework assignment. That means you can spend as much time on it as you want. You can start it when you want. You can end it when you want. You can keep going back to it and looking at the various problems again. That's designed specifically so that you can use it as a study tool. Right? So it's a practice test, and you should be asking yourself if you know how to do the problems that are on there. But it's set up so that you can spend as much time on it as you want. The exam does have a time limit, so you have lots of time. Like I mentioned, you're not going to run out of time working on the exam, but you do have to do it. Like once you start the actual exam, then you have a period of time until you finish it. So in other words, with the practice exam, you could work on it, some of it today, and then next week you could work on some more of it. And then over spring break, you could finish it up. The exam has a little bit different rules to it. Like the videos are not going to be available to you when you're taking the exam, right? It hides the videos. So stuff like that, right? So once you start make sure when you start the exam that you're going to take that you have a period of time that you can just focus on that. So wait till the kids are in bed, or you don't have work in 2.5 hours or something like that that's going to throw you off. Make sure you have a period of time to work on it as long as you want, because as soon as you start, that timer starts. And I usually give like 5 hours or something like that. It depends on the test, but like I give plenty of time, like, for a test that should take you an hour, I give like numerous hours, so that way no one runs out of time. But there is a timer for the exam, because the timer is supposed to be the test is supposed to be a little bit more rigorous. So the idea is you can't keep going back to it for 2 weeks and working on it. It's just supposed to know it at a higher level at that point. So just do be aware when you start the exam, make sure that you're in a place where you can finish it and get as many points as you can. Otherwise, you're just going to end up taking that retake afterwards. And the retake is fine, but it'd be nice if you got it done without having to do the retake. It'd be nice, for everyone involved if you just got it done the first time, and then you don't have to study a second time around. So that's kind of in your best interest to do it that way. Let's see. I got a couple chats here. Yeah, so I try to give everyone plenty of time to work on that. Oh, also, I forgot to check for this class. If anyone has accommodations just that are documented by the school, just make sure you contact me, and we'll, I always make sure all those accommodations are taken care of. So, I want to work to make sure those are done the right way. Let's see. Quick question. Do you happen to have the link for the Math for Meds access code to purchase off the site instead of the bookstore? Oh, good question. So someone's asking about the book. So that's the transition we're going to make over spring break. When we come back from spring break, assuming that you've passed the test and you don't want to do the retake, then you're done with the algebra portion of the course. Now, we are definitely going to have some algebra in the second portion of the course. Like, it will come up, but our main focus will be on doing the Math for Meds problems, and it's only going to be we're only going to use algebra in order to do the problems that we need to do for the Math for Med. So it's not going to be algebra for algebra's sake like it is now, where we're learning all these algebra topics. And when we come back from spring break, it's just going to be, any algebra that I need to cover to do the specific problems from the Math for Meds book. Now, the question is about that Math for Meds book. So I believe everything should be squared away. I set it up, and then I actually met with the rep who does the book stuff, and she said, nope, you have this all set up correctly. They made it like confusing because they're trying, it's really marketing a lot of their stuff. They'll have like 4 different versions of books and stuff. And she even admitted, she's like, yeah, we have like 3 different versions, but they're all the same thing. So it doesn't even make any difference. They just market it as like, they give it a different name, and it's like toothpaste. There's all these like different versions of toothpaste. Like half the time it's the same toothpaste. They just call this one like teeth whitening and this one like, tartar control or whatever. It's all just marketing, a lot of it. So here's how it works. If you click the homework tab, it gives you the information about the book, but this is not what you're actually going to have to buy. So I just want to make sure everyone kind of understands. The way this works is when we get there in a few weeks, I'll open up. I don't think it's available to you yet. Let's see. Right here, this is not available to you. See how it's not? See how it's got the circle here, whereas like these ones up here had the green check, means it's published. This one's not published yet. But this, when you click this link right here, which you don't see because we're gonna wait till it's till after the break. But what'll happen is you'll click this. It's gonna take you into the homework. You're gonna set up your account, and you can buy it directly right from there. So you'll be able to just, when you get in here and they're setting up your account, they're gonna say, "Hey, by the way, do you want to just pay for this right now?" And you'll probably say yes, because I've never seen it be more expensive to buy directly than the bookstore. Usually the bookstore costs a little bit more than buying it directly. And like, what's the point of going through the bookstore then? Sometimes what happens when you go through the bookstore is they'll have the ISBN off. Remember, that's what happened at the beginning of the semester, is they had some thing that they had happen on their end, which then there was a mismatch between what I requested and what they were giving. Those kind of errors can be avoided by just buying directly from here. So that link is not available yet because I want us to just focus on wrapping up the algebra portion. But once we do, when you go into this link to set up your homework, you can just buy directly from there. So you don't have to wait for shipping. Sometimes people find something and they're like, oh, I found something on Amazon, and they order it. This happens a lot. So this is why I kind of recommend that people don't buy things through Amazon. If you want to rent, that's fine. But when it comes to the licenses and stuff, I've had students numerous times where they order a book or a product and they go, oh, no, it's fine. It says it's going to be here in 3 days. So no worries. And then I go, I don't know. I've had bad experiences with that. And then the next time I see them, they go, oh, yeah, now it's not going to be here for 4 weeks. Well, at this point, 4 weeks is like it's like half the rest of the semester. So the easiest thing to do when I open this up is you're just going to just buy it directly from there. The only reason that there is really to go through the bookstore itself is some people have certain financial aid that they can turn in at the bookstore that you can't turn in if you buy it directly. So for those of you in that very special financial aid situation, then it might be worth it to you to go through the bookstore. But honestly, the easiest thing is you'll use the link that I give you and you'll just buy it directly. So you don't even have to prepare for anything. Now, what about having the actual book? If I can grab it here. That's up to you. When you buy this license, this online license, you're going to get an electronic copy of the textbook available to you. So you will actually have access to the textbook when you buy the online homework. Okay. So for some of you, that may be okay. I always recommend that people have the book. So if you want the book, you can pick it up. I've seen some people, I think it was my other class, the one that meets in person. My students were telling me they rented the book on Amazon for like $12 or $15 or something like that. So pretty cheap. To me, that's a no-brainer. If I'm taking a math class, I would never take a math class without the textbook. Part of the problem is that students just don't like to read books. They don't want to read. They don't want to open a book, right? So sometimes we'll have students that buy these books, and at the end of the semester, it's still got the cellophane on it. It's like never been opened. In that case, it like didn't really do that person any good. But in my opinion, if you don't use a math textbook when you're taking the class, you're doing it wrong. It's probably not going to go well, right? Most of the stuff we do, there's examples in the book. Considering that you're all going to be you're actually going to use this stuff in the future. Having a textbook that's on the shelf that you can look at a few years from now when you've forgotten some of the stuff and you can just look it up again, I would find that incredibly useful. Obviously, you don't get to keep the book if you rent it, but even like this is the 11th edition. Honestly, if you found yourself a 10th edition online and used that, it's probably way cheaper. And then you have it's basically like these editions don't change very much. They just change it so that like the old books get pulled out of circulation and they can charge for all new books again. So if you find yourself a 10th edition and it's like, I've had students find like 10th editions online for like $5 or $10, and then you just have it forever. That's fine. And then you have the reference for when you want to look something up and go, oh, there's this example in the book that's just like the problem I'm working on. And then you just use their example to work through your problem. That's what should happen. Now you can do that with the electronic version, and I have not actually used the electronic version for this book, but what I will say is most of the time these publishers, their electronic versions of textbooks, I'm cynical. I think they do it on purpose because they want you to buy the paperback book, right? They make them hard to use. They're hard to navigate. It's not like, the internet should be easy, especially if you're just looking for chapters. It should be like click, you go to the chapter. Okay, now you go to this chapter. It's not done well like that. It's like difficult to navigate through it. So if I'm in your position, I'm sitting in, you want to know what's going to work best, I would get myself a paper copy of the book, either rent it on Amazon for whatever, I've heard $12. As those books get rented, then the cheap ones get used and then the price goes up. So early adopters get the cheaper prices. But my students, just last week, they were saying it's still $12 on Amazon to rent it. I don't know what it's like today, but you can rent yourself the modern version, or if you want, just find yourself a 10th edition cheap. It's going to be cheap somewhere because no one's requiring the 10th edition anymore, so the value of those old editions just plummets. You can find yourself a 10th edition cheap, and then you have it forever, so that you can use it whenever you need to look something up, even if it's 2 years from now. My understanding is numerous students that go through this program end up getting their bachelor's degree at like universities. So you're doing something a couple years from now to finish things up. You got your book as a reference to go back and look up about dosages because you're studying for whatever, some tests you have to do or whatever. You can remind yourself how to do it. So that's totally up to you. And then someone asked about, I think it looked like someone was asking about the link. Are you going to put a link to the license in the same area as the Delta Math? I rented the book for $20. Okay. No, the link, so where is this link going to end up? Yeah, once I publish it, in fact, I can just kind of move it up since it's going to be important. Let's just move it up a bit. Yeah, we'll just put it here. So it'll be up at the top and it'll look like this. It'll have the title of the book, Curran Math for Med Single Term 11th Edition WebAssign, and then this will be available for you to see. And then you'll just use that link to go right there. Yeah, so the link will be up at the top once it becomes visible for you, and then you can go in. So, and I don't know what the cost is off the top of my head. A lot of times these licenses are somewhere in the neighborhood of $60 to $80. So I would expect this to be roughly in that zone somewhere, but they're always in fluctuation, even from semester to semester. You look at the price, or students tell you what they're paying, and then the next semester it's like different. It's always changes a little bit. Okay. So that's where the class is going in the next couple weeks and during this big transition. So you can view spring break as a big transition. You're finishing up the algebra. We're moving into the math for meds. For most of you, that's going to be a relief. My understanding is that the math for meds is much less stressful than the algebra portion as far as students find it. Right. And then right. And then just, and I think I got at least one student that emailed me about this that I need to get back to. But in general, it seems, and I'm not even really supposed to talk about it because we don't know what we don't even know what the changes are going to be. But it looks like because of, so what happened a few years ago, there's this thing called AB 705. And AB 705 made some legal changes to the way we run math and English departments at community colleges. So we've had to make some changes, and it appears like some changes are going to have to get made to this course. So I can't go into details because, like I say, those details haven't even been decided. But I would just say, if you're thinking of dropping this course, just be careful because this course is probably going to undergo some changes going forward. And like I say, I can't even tell you what those changes are because no one knows. They haven't even formed the committee yet that's going to decide what this course is like in the future. So it's not like if you ask the dean doesn't know either. The dean's going to find out after we do, and we won't even know for a while. So there's probably going to be some changes to this course in the future. I don't know what those are, but there's going to be maybe a transition in the near future about what's going on with the course. So just be aware, if you drop this course and try it in a different semester, it might be a little different than has been taught for the last few years. So that's up to you to decide what to do with it. Like I say, I can't even be helpful because even if I was allowed to talk about it, which I'm not, I was told I'm not supposed to talk about it, but even if I was, we don't know. So I don't have the answers as to what this course is going to look like, 6 months, a year, 2 years from now. We don't know, but there's going to be some changes that have to be made to it. So just keep that in mind if you're thinking about dropping the class or something, right? I know it's not helpful. I can't I don't even have the actual information to give you. No one does. The committee hasn't been formed that's going to decide this stuff, but just be aware. It may not be as easy as, I'll just drop it, and then since I've taken half of it, I'll be all ready for it the next semester. It might be a different semester, or it might be a different course when you go to take it in a different semester. And so it'll be more starting over from scratch. It won't be like, oh, well, I already know a bunch of this stuff, I'll just do it again. Maybe not. Depends what happens with this course. So just be aware of that. And then whoever emailed me about that, I'll try to get back to you and basically say the same thing in there. Oh, good time to take roll. Let's do that. Here we go. Okay. Thanks to everyone who threw your name in chat on YouTube. Let's see. Oh, right. You are back here. There you are. I got two similar names. Allison, are you Allison F? Or are you someone else? Somebody named iPhone. I don't know who that is. Oh, okay. So we got. Okay, Grace, I gotcha. And Franco. Gotcha. Okay, so what do we got? Let's see. I'm missing Alan C, Aurelie C, Nicole D, John G, James H. Oh, wait, I saw this name a few times. Didn't I see? Yep. Oh, somehow I didn't. Okay, got that person now. Leslie J, Tanya O, Cassie T, Angelica T. So if I just said your name, that means I don't have you down. So if I called your name, that means I have you not marked as being here. So just let me know in chat that you are in fact here, and then I can update the role. Okay? All right. Thanks, everybody. All right. I had a lengthy discussion there. Let's get into actual stuff. So like I mentioned, we're finishing up this last chapter for logarithms, properties of logs, solving logs, and that should all be up, right? So if we've got the, let me double check. View the assignments for, oh, did I not release the logarithms? Let me make a note here. It's like maybe I'm missing something. So logs, exponentials. Looks like maybe I didn't release some homeworks yet or something. So I'll do that today when we're done. It should only take me about 10 minutes or something to get all those done. So I can't tell if they're just in the wrong place. I thought I did that, but either way. So we have our last chapter to get through, so of the algebra, and that's logarithms. Logarithms are very confusing to people. I'll be honest, the first time that I learned about logarithms, I didn't really get it. I memorized how to do them, and I could get problems right, but I'll admit it was a while before I actually understood what was going on with the logarithms. That's not the way to do it, right? Sometimes you have to, and I realize that many of you were in math classes where you memorized how to do stuff. It's not great because later when people expect you to use the logarithms, you don't really know what's going on. Logarithms especially, right? So many of you are going to end up in chemistry classes, and chemistry especially, like other sciences as well, uses logarithms, but especially chemistry, like if you've got your pH levels and a lot of those kind of scales that they use for chemicals and stuff are actually logarithmically based. So you have to kind of understand what a logarithm is in order for those things to make any sense to you. So it's kind of important. We are moving through things kind of quick. My understanding is we won't be using logs that much in the second half of the semester, so we're not going to spend a ton of time on logarithms. Just kind of be aware if you're taking chemistry, you may want to spend a little extra time trying to figure out how these things work, because that's one of the complaints we hear from the chemistry department is like, our students get here and they don't know how to do logarithms. And it's like, yeah, it's a tricky thing to teach people because it's the notation is especially confusing. There's a few things that make these especially difficult. So we'll see how far we get. I'm not going to be able to cover everything about logarithms in the remaining a little less than an hour that we have left to meet today. So we'll definitely spill over into next time. And then next time, if you want, you can also bring questions and stuff that we can talk about during the during that class meeting. That'll basically be what next time is finishing up logarithms, and then with whatever time is left, I can answer questions, which can either be about logarithms or it can be about stuff from the practice exam. If you've looked at the practice exam and you know there's problems, you're like, wait, I need more help with that, we can look at those. There's numerous things we can do to make that stuff make sense. So we can do that. So first, let's just get into what is a logarithm? What is this confusing thing that he's talking about? A logarithm is really it's a different way of handling exponents. You sometimes hear people will make the claim, oh, logarithms are just exponents. Well, if that was the case, then why would we have logarithms, right? But there is something to that claim. When someone says that a logarithm is just an exponent, a logarithm is sort of the backwards way of dealing with exponents. So, there's a reason that we have them. And the reason that we have them is you have these functions that are called exponential, and they look like this. So I know last week I said most of what we were doing was on Zoom, but this week a lot of what I'm showing is on the YouTube stream again. So feel free to jump into the YouTube stream if you want. Feel free to stay on Zoom, but you're not going to be able to see the visuals on Zoom that I'm showing you on the YouTube stream. So it's whatever way you want to consume this material. So we have exponential functions, which are where you have a fixed base raised to a variable exponent. And it looks like what you're seeing on the YouTube stream right here. You can see the visuals that I'm showing you. That's what exponential functions look like. Now, a lot of people get confused and say, oh, 2 to the x, isn't that just like a polynomial? We did that. Remember all those quadratics where we do x squared? No, x squared and 2 to the x are different. So if you can see this, let me see if I can make this a little bigger so you can see it a little better. You want to know the difference between 2 to the x and x squared. X squared is a quadratic polynomial. Oops, looks like we got someone else here. All right, Leslie, I got you. Thanks. X squared, the black one, that's a parabola. That's a quadratic. And so that's what we've been dealing with. An exponential is where you have a fixed base and a variable exponent. So a polynomial is a variable base with a fixed exponent. An exponential is a fixed base with a variable exponent. Okay, so they're very different from each other. So when you look over here on the left, 2 to the x and x squared, you want to make sure you recognize which of those are different. I have students that get confused. I think it's just a matter of not looking closely enough, but you want to make sure you can tell the difference between these. All right, thanks, Cassie. I got you. Okay, so we're dealing with the red kind, like that, 2 to the x. That's an exponential function, is what we call that. Now, you run into a weird thing where we have these functions that we call inverse functions. And an inverse function undoes a specific type of function. It's like going back in time. You just reverse it, and you end up back with what you started with. Okay, so so you think of two functions that way. Let's say you have a function that maybe it's a price function. You put an item. You put some, like, what's it going to cost me to buy this many items of a certain type? You go to your vendor and you say, I want to buy 10,000 of these bolts. Okay, well, what's that going to cost? So you put in the number of units you want to buy, and the function gives you the cost. Well, the inverse function would go backwards. If you put in the cost, it would work backwards and tell you how many items you bought. Okay, so inverse functions are very, very important. And I see, looks like Alan showed up, so I got him covered. These are hugely helpful. Here's an example of when it can be extra helpful. So in most of your math classes, you've probably at some point done a retirement type problem, which is, okay, I have this much money. I'm going to put it in an account. I'm going to let it just sit there and grow for 30 years and see how much money I have left in retirement when I get to retirement. Well, that's one way to handle that kind of a problem, but that's not the most efficient way. What works better is to say, well, when I retire, I want to have this much money, and then you work backwards and figure out how much money do I need to start with in order to have it grow to the amount of money that I want to end up with. Well, the first type of question I described, which is use less, that's the easier one to do. The second one I described is the inverse. You actually use the inverse function to do the problem backwards, and it's actually the more valuable of those two in the particular case that I talked about. So sometimes we just need inverse functions of things. So the exponential function, right, if you sat about using your tools for inverses, how to find inverses, you run into some difficulties, and you kind of end up scratching your head and going, I don't know what the inverse of 2 to the x is. How do I figure that out? And it's one of those things that was a little tricky in mathematics, and then they defined this thing to be the inverse. So basically, that's what the logarithm is. We define it to be the inverse because we know, like, exponential functions are hugely important. They end up all over the place in mathematics, in research, in business, and every area being studied out there. Not every area, but a huge number. You'd be surprised how many use exponential functions. Well, we want to be able to turn those questions around in order to answer other interesting questions, and for that we need the inverse. And the inverse is the logarithm. So when we get to the logarithm here, let me make sure I get my wording exactly right. I don't want to mess it up the first few times. Okay, so here's our definition for b not equal to 1 and b greater than 0, then, and this is not updating, let's go auto compile, then y equals log base b x means x equals b to the y. Okay, so here's our definition of the logarithm. Let me put this on a different line here. Okay, so for our base, our b in this problem is the base. So you see the b over here by the log. It's kind of a subscript down on the, like, kind of almost like submerged there underground a little bit. And then over here we have the b over here. It's the same b. We're just writing it in a different spot. So that b cannot be equal to 1, and it cannot be less than 0. So you can write these exponential problems with a negative base, but they do really weird stuff, and it doesn't, like exponential functions and stuff they can represent compound interest. They can represent growth rates of bacteria in a petri dish. Many things can be represented with exponential functions. But if you use negative bases, they get this really weird behavior that you don't really see in most situations. And if b is equal to 1, then you just get the constant function y equals 1. We don't want any of those cases. So b has to be greater than 0, and it cannot be equal to 1. Oops, looks like I've now cut this off. Let's put this on a different line. Okay. Then what happens is we have our definition for the log right here. Y equals log base b of x means x equals b to the y. Now, you want to know this definition inside and out. Like, you want to have it memorized like you know your name. And I know a lot of times I'm saying don't memorize things. You sometimes need to memorize things in mathematics. You also should know how to use them and what they mean. But sometimes you just have to have this stuff memorized. So a lot of times what's going to happen is you're going to have something in this log form, and you're going to look at it and go, I'm really confused by that notation. It says log. I still don't really understand what the log is. I don't know what I'm supposed to do. And a lot of the time, if you convert it from this form with the log and you convert it over to this exponent form, maybe like half the time, as soon as you write it in this form, you're going to go, oh, I know what to do. I see what I'm supposed to do now. It's this log form is confusing for people, especially the word log throws people all off a little bit. So you want to be able to go back and forth between these two definitions. If you're given the exponential form, can you write it in terms of the logarithm? If you're given the logarithm, can you write it in terms of the exponential form? And I would say probably half the times, at least when we're in class, when my students get stuck, they're stuck on this log version, and I say, convert it to the exponential form, and as soon as they do, they go, oh, I know what to do now. I know how to finish the problem. Okay, so if you're ever really stuck and you don't know how to progress, try seeing if it makes sense in the exponential form. So how do we go back and forth between these? Well, it's literally just rewriting the symbols in the other way. So here we have the log form, where this log is indicating a function. The log is a function. Okay, it's the inverse function of the exponential. So we write the little base b down here, and then you've got your x and your y. Well, see how right here we say that y is equal to the log base b of x? And then notice that over here, y is our exponent. So kind of use the transitive property here. If y is an exponent and y is also the logarithm, then the logarithm's an exponent. So you can see, sorry, I thought I was going to sneeze. You can see like the comment that I made earlier where some people will say, oh, logarithms are just exponents, is kind of partly true. There's truth to that statement. I think it's an oversimplification and can actually be misleading sometimes. But you can see, yeah, y is equal to a logarithm. And over here, y is our exponent. So in some sense, the logarithm's an exponent. Yeah, you can kind of think of it that way. But notice what's happening is the problem with when we were trying to solve for an inverse for a logarithm is it's hard to do algebra up in the exponent. So what this does is it allows us to write the exponent on a normal line, but we just have this confusing notation of the word log, which throws people off because it's not like obvious. You think of a log, you're like, oh yeah, like a piece of wood out in the forest, right? You don't really think about, like, it's not a mathematical term that you think of right away. I mean, it becomes one, but it's just kind of weird, log. And log is short for logarithm. So the way we write these is we want to be able to go back and forth between these two forms. So for instance, we can have, I can write 3 equals log base 2, 8. Okay, so here's a logarithm written out. You can see it's just, I just have this thing up here, except I put in values for x, y, and b. So the values are appearing here, right? But what does this mean? And notice also, this does not mean 2 to the 8th. I know people will look at this because I have students do this when we're in class, and they go, oh, 2 to the 8th is whatever it is, 2, 4, 8, 16, 32, 64, 122. They go, oh, 2 to the 8th is 256. That's not what this means right here. This is not 2 to the 8th. That's not how you want to read that. So the way you read this is this 2 is just a subscript on the logarithm because, as we mentioned, you can have logarithms of lots of different bases. They can even be fractions. They can even be irrational, like pi. As long as they're not equal to 1 and they are greater than 0, then that's a legitimate base for a logarithm. So there's an infinite number of the ones that you can use. Well, this subscript is just letting you know that we're talking about the log base 2. Okay, so the 2 goes with the log, not with the 8. So don't think of this as 2 to the 8th. That's not what that's supposed to be. Okay, so how do we convert it using our exponential form? Well, just track everything. So this says that the y becomes the exponent, and the b, the base of the logarithm, becomes the b. So on one side, we're going to have 2, which is the b, raised to the 3rd power, which is the y. So our b to the y becomes 2 to the 3rd, and it's going to be equal to the x value, which is 8. So when I rewrite this, it just becomes something that all of a sudden you go, oh, yeah, okay. It becomes 8 equals 2 cubed. See how over here that's really easy to understand, or hopefully it's easy for you to understand with the algebra we've done so far. You go, yeah, 2 to the third power equals 8, right? 2, 4, 8. That makes sense. Oh, 2 to the third equals 8. Okay. So 3 equals log base 2, 8 really means that. So this is like a confusing way of writing this thing over here. Okay. So you can see, I know at first when we give this definition of the logarithm, it's very confusing to people. But actually, you want to get in the practice of being able to convert back and forth between these two forms very quickly. Okay, so let's try another one, but this time with a piece of information missing. Okay, let's try this. So 3 equals log base 5 of x. So in this case, they're going to want you to find the value of x. They're going to say, what's x down here? Give me the answer for x. And you know, some of you might be able to do this by looking at the log problem, but some of you are going to look at this and go, I don't know. What is that supposed to be? I don't get what's going on. So what you're going to do is you're going to rewrite it in exponential form. So you're going to go, okay, so if I convert this, let's see, I've got my, it says x equals, okay, my base is 5, and I'm raising it to the third power. And then you go, oh, that's 125. 5 times 5 is 25, times 5 is 125. Oh, x equals 125 then. And you'll have your answer. So see how even when one of these pieces of information is missing, you frequently can figure out what that information is. Okay, and we can do any of the pieces can be missing. So for instance, we can be missing another piece of information. I can do, let's see, if I want to do this a little bit differently, why don't we go y equals log base 3, 27. So we see this, and they ask you, what is y? What is y equal to? And you go, I don't know. I'm confused by that. I'm not comfortable with logarithms yet. Rewrite it as an exponential. So it now reads, let's see, our base is 3, and we're raising it to some exponent that we don't know what it is, and that's going to equal 27. Oops, put my equals in the wrong place. There we go. Okay, so 27 equals 3 to what power? So you sit there and think about it and go, I don't know, let's see. 3 times 3 is 9, times 3 is 27. Oh, it looks like the thing that we're missing, the exponent, is a 3. 3 cubed is 27, so that's the thing that's missing. So y, your answer here would be that y equals 3. So you see how whichever variable they give you, whichever piece is missing, you can convert it to the exponential, and then you can solve that problem. Okay, now this gets more complicated, but we're starting off with like easier problems where you can kind of see it right from the beginning and go, oh, I see what's missing there. I get what's going on. Okay, and we do that. So that's the basic of the the logarithm from the definition. And then we start getting into cases that start to get a little bit more confusing. But the truth is these fall back on your rules of exponents. So if you understand your rules of exponents really well, you'll be good to you're going to pick a lot of these trickier logarithms up a lot faster. Okay. For example, let's do this one. Let's go to a new page here. So, oops. So let's do, so say you're just given log base 5 of the fraction 1 over 25. And then you're told, what is this equal to? So you see in the last one, we had like log expressions that had an equal sign in them, and you had to figure out the variable. Sometimes they just give you this, and you have to figure out what it's equal to. So in this case, remember the pieces. Like, you want to learn these pieces inside and out. Your base is the subscript by the log. Your exponent is this piece that's over here by itself on one side of the equal sign. And then your answer is this x that's next to your log. Okay, so we want to dissect those pieces. So for us, let's see. This 5 right here is my base. That's my base of my exponent. We don't know what the exponent is because it's missing. And then over here we have the answer. What is that equal to? Now in this case, if you don't remember your rules of exponents, some students even struggle and go, even when it's in the exponent form, I don't see what I'm supposed to do with it. So let's take a look. So if we transpose, or if we translate this, we get 5 raised to some variable equals the fraction 1 over 25. Okay, so bonus points to you if you can remember how this works. That means you're on point. Okay, so what power do I raise 5 to get it to be 1 over 25? Well, let's remember our negative exponents, right? 5 squared is 25. 5 to the negative 2 would mean that I move my 5 to the negative 2 to the bottom of the denominator, change it to 5 squared, and I have 1 over 25, 1 over 5 squared. So x in this particular case would be negative 2. You just have to remember to use your negative exponents, right? You have to remember how those negative exponents work. Okay. Those come up. So, also here's another one that throws people off. It's those rational exponents that we looked at in the chapter where we were solving equations with radicals and stuff. This one will throw people off. So let's say we've got, let's do it this way. So you've got log base 7, square root of 7. So again, we're missing our exponent. What exponent do I need to get 7 to be square root of 7? Well, those of you who are, practiced up on your radical equations and all that, that whole chapter will go, oh, that's 1/2. Something raised to the 1/2 exponent is the same as the square root of that thing, right? So this really translates to, so this means we have 7 raised to a power equals the square root of 7. If you go back, if you forget this, if you go back and look in that chapter, you'll go, oh yeah, it's 1/2. 7 raised to the 1/2 is the same as square root of 7. So that's a thing that throws people. It's like if you're good with these rules of exponents, these will come quick. If you're still kind of struggling with those, these are going to take a little bit more time. Right. Yeah. So for a bunch of these, just write it in exponential form, and you'll figure out how to go through and simplify these. So let's see. So we got those. Oh, the graphs of logarithmic functions, just so you know. The way inverse functions work is if you have a function and you reflect it across this line y equals x, you get the inverse. So our inverse function, let me make this a different color. Make it light since it's not as important. So if we do log base 2 of x, see how if I folded this along the orange line, this red line would line up on the blue one? This red line is the exponential base 2. This blue one is the logarithm base 2. Okay, and notice how there's no negative values for our logarithm. Our logarithm comes up along the x-axis or the y-axis and then hugs it. It doesn't go over into negative territory. What that means is you can't take the log of a negative number. You can't take log of -3 or log of -7. Doesn't work that way. So, oops. So that's what the graph of a logarithm is going to look roughly like that. Okay. We're not going to get real deep into graphing logarithms in this class. We're not going to do it in this class. We just don't need to get super in depth into it. But like I mentioned, these logarithms do come up they come up occasionally in business, but more often in science type stuff, you're going to see logarithmic stuff. A number of scales are done logarithmically, which means you're actually looking at powers of things and this is convenient to do. Sometimes you'll see people graph things on a logarithmic scale. Even if they're in business, I've seen it done in business and stuff before where they graph things logarithmically. And this is usually because if you try to graph things like in a normal sort of linear pattern, you end up with really distorted graphs where some of your graphs, certain portions of your graphs are so small that it's hard to see the behavior of your graphs. So they make them logarithmic. What this means is things don't behave in a linear manner because they're going up exponentially. So when you see something that looks linear, it's actually an exponential growth you're looking at because your scale is logarithmic. This is confusing for people, but this is why, like, if you compare earthquakes, right? So if you're in this class, you probably have felt numerous earthquakes in your lifetime. Some tiny earthquakes, some a little bit bigger. Was a few years ago we had like that 5.4 here in Ventura, and I was on that. I was inside my office in the science building, which is a mess. That building is a disaster, and it shook that building enough to be concerning. That like the building didn't sound like it was really liking being shaken in that way. So you can have kind of an alarming level earthquake depending on what kind of environment you're in the 5s or whatever. But then you hear about these bigger earthquakes that cause a ton of damage. Like the Northridge earthquake was like a 6.2 or 3 or something like that. And like the one we had in Ventura a few years ago was like a 5.4. So you kind of think like, well, that 5.4 earthquake like didn't really cause any damage. I think a few things fell off of shelves and stuff like that, but like no structural damage or anything like that. So a 5.4 is enough it doesn't damage buildings, but then a 6.2 is enough that it damages like tons of buildings? Like what's going on there? And the reason people fail to understand what's going on is they think about the earthquake scale. They assume that it's a linear system, so that a 6 is about 20% more than a 5. That's not how it works. With logarithmic scales, since the logarithms are exponents, things go up exponentially. So with the Richter scale, a 6.0 earthquake is 10 times more powerful than a 5. And a 5 is 10 times more powerful than a 3. So that's why when you start comparing earthquakes and you're like, well, I've been in a 5, and yet this earthquake on the other side of the world that was a 7, like destroyed entire cities and killed like thousands of people. How is that possible? Well, that's because a 7 is not just a little bit more powerful than a 5, like if you were looking on a linear scale. It's 100 times more powerful than a 5, because a 6 is 10 times more powerful than a 5, and a 7 is 10 times more powerful than a 6. So the 7 is 100 times more powerful than a 5. So if you've been in a 5 and you're like, that didn't seem too bad, it was a little, kind of caught my attention, but it wasn't that big of a deal. And then you see in Nepal or something, they have like a 7.2, and it was like devastating effects. That's why. That earthquake was 100 times more powerful than the one you were in. People miss these things because they don't understand how logarithms work. They don't understand that the scale is logarithmic. People tend to assume that everything is linear, where, 7 in general is a little bigger than a 5. This is what they do if you go to if you have a kid and you take them to the doctor and they have that little chart where it's like, on the scale of 1 to 10, point to the smiley face that tells you like how bad you feel, how bad is your pain or whatever. Like that scale is more linear. Like as you move to the right, the changes are about the same as each other. Where on an earthquake scale, each time you go to the right, it's 10 times worse than the one before it. It's the same thing with decibels. right? People completely misunderstand how the decibel scale works. The decibel scale is logarithmic base 3. So every reduction by 3 on the decibel scale, you actually perceive as half as loud, right? And that one, I see people make mistakes, because I've done stuff with like sound before, like music production and stuff. People get really confused when it comes to like dBs. If you have like if you have any kind of audio equipment at home and it's got dBs on it, people do that all completely wrong because they treat it like it's a linear scale when it's logarithmic. So numerous places where this comes up, pH scales in chemistry, lots of things. If you're thinking about it as linear, you're going to do it completely wrong. Just recognize it's a log scale. Right. Where are we on time? We got about 20 minutes. Okay. Okay. We do have some special logs and exponentials. So there are two that come up a lot. So one is there's this special number e in mathematics. We call it e. It's like pi, where it's an irrational number. And you might go, no, right there. It's 2.7182181828846. This is a approximation. E has an infinite non-repeating decimal expansion. You can't write it as a decimal. You'd be writing forever because it's infinite and it doesn't repeat. Like 1/3 written as a decimal is repeating. You just write it as 0.3 and we put a bar over it to indicate that it goes on forever. With E, you can't do that because there's no repeating format to these decimals. It's just always changing. That's why we give pi and E symbols, because you can't write them in decimal form. So we just say, we'll write this symbol and everyone knows what that thing is. Where does this number E come from? Like, people know where pi comes from. It's the ratio of the circumference of a circle to its diameter. That makes sense. You can draw a picture of it. E is a little trickier, although E comes up, I would argue, in more places than pi does. It's hugely important. So where did that number pi come from? How do we come up with it? You need calculus to come up with that number. So we give it to you for now. Those of you who take calculus, you'll learn. It's like you spend, it's an exercise you do in class. You go, oh, that's where E comes from. It's actually based on calculus. So for now, you're just kind of going to have to trust me about this number and where it comes from. And then those of you if you ever take calculus, you can sort of learn where it comes from. But this number E has some very interesting properties that make it really convenient to use in lots of scenarios. This E is being used in parts of your life that you don't even know about, right? I mean, it makes pi look silly, that E gets used in so many different places. Calculating continuous compounding interest, right? You use this number E. Most probability density functions use E. So when companies are figuring out your premiums for insurance rates based on, the probability of you dying under the fact that you're a 37-year-old single parent who smokes but exercises regularly, all this, all the stuff they come up with to calculate the probability of how much you're going to cost and are you going to die in the next year, all that stuff is done has an E in there somewhere. Population growth, you use E, all sorts of stuff. This number E comes up. It's a very important number. So because of that, this e to the x exponential is really important, but also so is the corresponding logarithm. The base E exponential has as its inverse what we call the natural log, right? ln x. And you can see that same relationship where they reflect across that line, y equals x. Okay. So the natural log, we call it ln, and people go, why is it natural log if it's ln? Wouldn't it be nl? I think it's from the Greek, and so it is either Greek or Roman, or it's probably Greek, where they write it in a different order. But ln is the natural log with base e. That's all it means. So if I have log base e x, notice that's the same function. Whoops. Notice they're right on top of each other. That's because log base e, we just write it as ln. It's just a shorthand notation, but it means the logarithm with this base e that gets used. That's probably the most used logarithm out there, right? A huge percentage of the time that someone's using a logarithm, it's probably base e, right? The other one that comes up a lot is base 10, because we use a base 10 number system in this country, and most of the world in modern times uses a base 10 number system, largely because we have 10 fingers, and so it's easy to just use 10 as our base number for our system. What that means is we have 10 symbols that we use in our number system. There are other convenient number systems you can use, especially things that have lots of divisors. So in the past, there have been civilizations that use base 12, base 18, base 24. They use these different number systems, which for certain things, very, very convenient to do. Sometimes it makes division really easy. Certain types of problems are way easier in certain base numbers than others. But we use a base 10 number system, so it makes sense that we would regularly be using the base 10 logarithm, which is like the second most used logarithm. Number one most used logarithm is base E. The second most used is base 10. And then like way, way behind that, you get the third place, which is base 2. The reason that base 2 gets used a lot is because of computers. Binary in computers and all that kind of stuff where there's just two choices. So if you're going into, well, probably most of you are not going into computer science because you're in a nursing class. But if you know people that are going into computer science, or you have a penchant for learning some computer science or something, you're going to be using base 2 logarithms frequently. And then after third place, there's like almost nothing else. Like all the rest of the logarithms, how often they get used is like just barely even a sliver. So the three that you see on a regular basis, natural log gets used the most, then base 10 logarithm, and then far behind is base 2, because like I say, it's kind of a mostly computer science thing. Those are the three big ones. You will run into situations where you occasionally have to use base 4 or base 6, something like that, but not very often, right? You might see it on the homework, but in real life, it's usually one of those three that you're looking at, okay? So those are the ones that get used a lot. So just kind of be comfortable with those and how they work. Okay, so once we have these logs defined, then the question is, well, what do we do with them? How do we manipulate logs? Like when you start dealing with variables, what do you do after that? You start adding, subtracting, multiplying, dividing. We come up with operations for using on algebraic expressions, and then then that gives us the power to start doing stuff. The same thing happens here. What if I have logarithms? How do I add logarithms? How do I multiply logarithms? Like, what are the operations that we can do to simplify logarithms? How does this work? And it's kind of a complicated question, so let's dive into it. In fact, let me show you. I've got on here properties of logarithms. In fact, for the sake of time, whoops, logged me out there. Here we go. Properties of logarithms. I've got videos here inside of Canvas. So if you just go, you've got your normal Canvas page. You go down to the logarithms. We kind of just covered this, conversions from exponential to logarithmic form. I've got some videos in there, and you can watch those. But that's really the kind of stuff we just talked about, right, is about doing those. And then if we go to the next one, well, let's go back just so I can show you. We've got the properties of logarithms, and there's a bunch of videos for those. So see, you've got these videos here, and it's basically laying out the different properties that you've got in order to manipulate logarithms. Now, in 14 minutes, I'm not really going to be able to go over these. I think you're better off left watching them and then following along. So what happens is you start off by learning these properties isolated. So you're going to watch a video like this one right here. You're going to watch it. This one's called the product rule. So you're going to watch how to apply the product rule to a logarithm. And then you're going to watch how to apply the quotient rule to the logarithm. Then the power rule. But what happens is at that point, once you've learned all the rules, they start giving you problems that use like 3 or 4 rules. So you have to apply 3 or 4 rules all at once. And sometimes that's a point where I know students get stuck and they're like, all of a sudden they're like, whoa, what? We didn't do any problems like this so far. What you need to do is break those problems down into smaller pieces and ask yourself, is there one rule that I can apply to this? Because there's not like a new rule. It's just using like 3 rules in a row. So just ask yourself, what's the next thing that I can apply? Can I use that product rule? Can I use the power rule? And there's an infinite number of combinations, right? So I can't just say, like, what I'm about to say is wrong. I'm just giving you an example of what I can't say is always do the power rule first, then do the product rule, then use the 0 exponent rule. Like, it doesn't work that way because there's an infinite number of different combinations of ways that we can combine these logarithms together, or that they need to be combined together. And so you just have to look for a rule that works and ask yourself, can I use that one rule? So for instance, here's where this comes from. Let me kind of derive it for you. Where am I? Right here. So let's go here, and we've got what was the, sorry. Yeah, okay, right. So we've got the log base b of mn equals the log base b of m plus the log base b of n. So remember, we've mentioned a couple times here how logs and exponents are related to each other. Well, they are. And the truth is, if you ever want to see where these log rules come from, it's just a rewriting of the exponent rules. So remember when we talked about exponents and we looked at those exponent rules? This is literally just an exponent rule, but written in the form of logarithms, right? So remember what we did when we had, remember this rule right here? Where we had a to the m, a to the n equals a to the m plus n. This was one of our logarithm or our exponent rules that we had, where when we're going to multiply these two things together, we add the exponents. Well, I'm not going to go through the whole derivation because we don't have time, and also it's not really necessary for this class, but I just want you to understand this log rule is really like, if we take this exponent rule and we write it in the language of logarithm notation, you'll get this log rule right here. And you can kind of see it, right? Because remember we talked about logarithms being exponents, and here we have a product, and over here in this rule we have a product, and then over here we have two things being added together. And what did we say? Logarithms were really a type of exponent. So over here on the right I have two exponents being added together. Sure enough, that's what I have down here, is two exponents being added together. Oh, okay. So even though we're not working through every bit of the connection, you know, hopefully you can start to say, oh, I see what he's talking about. That, like, how, you know, here I have two exponents being added. Here I have two exponents being added. I can see there's a connection between these two things. So that's just to give you an idea of where this is coming from. It's not just magic that I made up out of the air somehow. It's actually relying on our previous knowledge, but unfortunately we don't have time to go through all that. So the key is you can break up and combine logarithms. A lot of times when we give you formulas, you're only supposed to go one direction for it. Like generally when you factor, I guess factor you have both. You can factor or you can multiply polynomials. But a lot of times when you're given a formula, people are used to starting with the thing on the left and then they end up with the thing on the right. Well, with logarithms, you go all of our formulas kind of go both directions. So sometimes you'll be using it working from left to right. Sometimes you'll start on the right and you'll work to the left. So for instance, we might have this. We might have a problem where they say, like, let's do this one. / log of 1,000 x. And I tell you to simplify this. Well, there's a couple things I didn't, or there's a one detail I didn't tell you, because you might be looking at that log and going, oh, he forgot to put the base on there. He forgot part of the logarithm. Actually, I didn't. So with logarithms, when you don't write a base, it's understood that that logarithm is base 10. Okay, so it's kind of like with square roots. When there's no index written on the square root, you know the index is 2, meaning it's a square root. It's the same thing here. When your logarithm has no base written there, you know it's a 10. Okay, we only write it when it's something different than a 10. And if it's e, then you write it as ln. Okay, so in this case, even though it's not written there, I know I'm dealing with a base 10 logarithm. But we want to simplify this. And I go, okay, so what does my rule tell me to do? This says I should rewrite this as the log of 1,000 plus the log of x. That's what, oops, what did I do? I think I needed a space there. I didn't like it for a second. Okay, so what did I do here? Well, according to our rule up here, I'm taking the two things that are a product. Here I have 1,000 and it's multiplying x. Here I have m times n. And we split it into the logarithm of each piece. Okay, so this becomes the log of 1,000 plus the log of x. That's what this rule is allowing us to do up here. Okay. But now we can simplify this log of 1,000 piece. How do we know I can do that? Well, the log base 10, right? This is a log base 10. So that's saying what? I have a base of 10 and an answer of 1,000. So that's really asking me, what is the exponent that I use to make 10 become 1,000? Well, start taking powers of 10. 10 squared is 100. Times 10 is 1,000. So log of 1,000 written this way is actually the number 3. It all simplifies to 3. So this becomes equals 3 plus log base x. Now the log base x we can't simplify any further. What's going on? The log base x we can't simplify any further. But the log of 1,000 could be simplified, and of course we always want to simplify things when we can, because why is this not compiling? Come on. Oh. There we go. Equals 3 plus log x. That's how you would do that problem. So, and if you're confused by that, again, you're just thinking exponents. The base here is 10. What do I raise 10 to get 1,000? The answer is 3. Okay. So you're going to go through, you're going to look at those rules of exponent, or rules of logarithms. We call them properties of logarithms, but really they're just theorems. I'll pick up next time where we discuss more about those and we work with them more. And then we're going to wrap things up with, is it equations? Yeah. Exponential and logarithmic equations. We're going to get into how to solve a bunch of those kind of things. There's a few different methods we're going to have to use to solve those equations. So we're going to learn how to do that. So in the meantime, work on, I think you can probably get the rest of the properties on your own, but I'll start off next time with a few problems. So try to get through the properties on your own. If you can't, feel free to bring problems and we can look at it. But work on the understanding the logarithms, that basic definition of the logarithm, and then also the properties, and try to get a hold of what how the properties work. We'll talk briefly about properties next time. We'll also talk about the logarithm and exponential equations and how to solve those. And then that's basically going to wrap up the algebra portion of the course. And then if there's time, you can also ask about problems from the review. And of course, you can come to office hours. You can go to, and you can feel free to take your study guide with you if you want to take your laptop to the tutoring center or make an appointment with the tutoring center for a Zoom meeting. You can do that. And, you know, it's not cheating to get help on your practice test. You know, I would like you to take the, be ethical when it comes to actually taking the test. But as far as the practice test, it's about learning. So feel free to get help with it, either from me or a tutor or other people in the class, whatever you need to do. In fact, I'm going to throw up I'm going to put a discussion up there for people to discuss problems from the practice test so that you can like help each other out. I highly encourage you to use that. Sometimes classes don't use it very much, but you're all in the same class, which means you're working on the same problems. You might as well be helping each other out and explaining things. And it'll be a graded assignment. So if you go in there and either ask a question or answer somebody's question, you'll get some points for doing it. Okay? So I'll put that up. I encourage you to make use of it. Not only is it some free points, but also you can, get some help is kind of the point of that. Okay? So I'll shut down the YouTube stream. I will stick around in Zoom as long as anyone has questions. I am going to see about that logs and exponentials homework and see why it's not up. And I will remedy that in the next few minutes. And then also I'll put that discussion up so that people can start putting in comments to get points for the practice exam. And then anyone who wants to stick around and talk to me in Zoom, feel free to do so. Okay, thanks everybody. Good job.